Hello and welcome back to Math 1500 Applied Business Mathematics. This is section 7.1. We're going to talk about sets and set operations. And actually there's not going to be a lot of heavy math in this section. It's a lot more definitions. Okay, when we look at a set, what we mean by a set is just simply a collection of items. And it's referred to as the elements of a set. So for example, I'm going to say set F is the set of fruit that my wife has in our refrigerator. We have an apple, a banana, and a pear. And so those are the fruit that we have in the refrigerator, so there is a set. It's simply a list or a collection of items that you're talking about referring to. We will usually use a capital letter to name a set. We typically start with A, set B. If I'm going to talk about fruit, I might use set F. If I'm going to talk about students, I might use S to represent the set. Okay, and we use braces to enclose the elements of the set. Okay, it takes a little bit of practice to make those. That's what we mean. This symbol here means element. X is an element of the set A. Okay, if X is not an element, we write X is not an element of A. So that's simply a notation there. If B equals A equals B, that simply means that we're saying that the two sets are equal. It's quite trivial actually, because if both sets are equal, then both sets have the same elements. So if I say that the set of fruit in our refrigerator, we have an apple, banana, and pear, and in your refrigerator, you have apple, banana, and pear, the sets would be the same. They have the exact same elements. Okay. We've got this symbol, which means subset. B is a subset of A, which means that every element of B is also an element of A. If B is a proper subset, that means that the sets are not equal to each other. So for example, let's suppose that set A is the numbers 2, 4, 6, 8. B is the numbers 2, 4, 6. Notice that every element in B is also in A, therefore B is a subset of A, or a proper subset. It's really kind of trivial if we were to say that set B was 2, 4, 6, 8 was the exact same as set A, we could technically say that B is a subset of A because B has less than or equal to what A has. And again, that would be a trivial case. So it makes a lot more sense if we were to say, notice that B, all the terms in B are also in A, but not all the terms in A are in B. B is a subset. B is a proper subset of A. The null set, or the empty set, is the set that has no elements. It's a subset of every single set. That seems trivial. Here's something that people get confused with. That null, that means it's the empty set. There are no terms. Some people will write it as an empty set, a set with the braces that's just empty. That's also okay. This, however, let me draw that more clearly, is not the same thing. I can't write that because that means I have a set of all these symbols that are circled with a slash through it. And that's just not okay. So let's get that out of here. I could write empty set either the 0 with the slash through it, or the set that's empty. Okay. We talk about finite sets. A finite set has finitely many elements. An infinite set, it's infinite. Does not have infinitely finite sets. Does not have finitely many elements. For example, I said that set A was 2, 4, 6, 8. Just 4 terms, that is a finite set. If I were to say that set B is 2, 4, 6, 8, 10, and on and on and on, therefore B is a set of all even numbers, there is no end to set B, so set B would be an infinite set. It's not finite. It does not end. Okay? We're heading into a section here looking at probability. And in probability, we look at what's called a set of outcomes. Or if I do an experiment, I do some activities. So if I toss a coin, there are two possible outcomes. The outcomes are heads or tails. So S, the set of outcomes, is HT. H for heads, T for tails. If I roll a six-sided die, there are six possible outcomes. So S is the set of possible outcomes. I get a 1, 2, 3, 4, 5, or 6. So that would be the set of possible outcomes. Okay. Another thing that we look at when we talk about sets is we talk about Venn diagrams. Venn diagrams are a great way to represent data and information. It's something that not a lot of people love, but they're not that bad. Okay. So, for example, an athletic director notices that at his school there are 42 students who play football, 14 who play baseball. However, 8 of the students play both football and baseball. If I want to draw a Venn diagram to represent the situation, I'm going to draw one circle to represent football and another circle to represent baseball. Notice that the circles overlap. The reason that the circles overlap is because I have some students, 8 students, play both football and baseball. So in this overlap is the students who play both football and baseball. In this section of the circle, that does not include the baseball. These are students that would play football only, not baseball. Notice that there are 42 students who play football, but 8 of them play baseball. So here is going to be 34 students, because that's 42 minus 8. The 42 people who play football minus the 8 who also plays baseball. So there's 34 students in that circle. Then, if I want to look at the students who play baseball, notice that there's 17 who play baseball, but of those 17, 8 also play football. So there are 9 students who play baseball only. Okay? So that's just a great way to see how many students we're talking about, where's the overlap, what do they have in common, what do they not have in common. Okay? Fairly short video here. We're just going to talk real quick about operations. Union. Union is or. Okay? Union means or. So A, union B. This symbol means union. It almost looks like a U. That's A union B. That's the set of all elements that are either in A or in B. If I want to know the students who play football or baseball, I would include the 34 who play football only, plus the 8 that play both, plus the 9 that play baseball only, and that would be a total of 51 students. Now, we might be tempted to say 42 football players and 17 baseball players. If I have 42 football plus 17 baseball, that looks like I have 59 players. But don't forget that we want to subtract the 8, because those 8 students who were counted, who played both sports, were counted with the football players and with the baseball players. So there's actually only a total of 51 total players. This symbol here, that looks like an upside down union, means intersection. The intersection is all elements that are in both A and in B. This does not mean I want to include all of the football players and I want to include all the baseball players. Believe it or not, that's actually an or statement. If I want and, I want to know those that are in both set A and in set B. A union B here would be the 8 players who play both football and baseball. They're in both groups. Think about a team photo. If I take a team photo of the football team and a team photo of the baseball team, those people, those players that are in both photos would be the intersection. Okay? And then complement. A complement, we put a little prime or a little apostrophe there. It means the set of all elements not in A. Okay, so if I have 51 athletes, okay, complement of football would be the 9 players who don't play football. Okay? So let's just real quick, let's suppose that we're looking at S as some universal set. S is the set of the letters A, B, C, D, E, F, G, H. A would be A, B, C, D, and B is C, D, E, F. If I want to find the union of A and B, I list all of the letters. A, B, C, D, all of the letters in set A, and all the letters in, or the elements in set B. I don't need to relist the C and the D, they're already there, but I'm going to include the E and the F. Okay. Now the intersection of A and B, this is the intersection of A and B in number 2, that would be the letters that occur in both sets. The letters common to both sets are C and D. So the intersection is just C and D. And then B complement. That would be the letters that are in the universal set S, not contained in B. So you'll notice that set S has A, B, let's just do this, C, D, E, F, G, H. But we want the complement, so we don't want to include those letters that are in B. So B complement would be A, B, G, H. Make my H more clear that time. All right, so that's just a quick look into sets, set notation, a little bit of operation with sets. Again, I hope, like always, I hope that this was helpful, and I will see you back for the next video.